Hi, this is David. Welcome to Part 1, Topic 1, Amenc Chapter 4 as part of the Part 1 readings. And this really refers to what I sometimes call the risk-adjusted performance measures, or RAMPMs. Although that's a very broad class of measures, the assignment here in Part 1, and it's really the third reading, it's not even the whole chapter that's assigned, you probably noticed, but it's just a section of Chapter 4, which is called Applying the Capital Asset Pricing Model to Performance Measurement, Single Index Performance Measurement Indicators. That single index really refers to this capital asset pricing model. You may recall that's our most popular single factor model, where the factor is the excess expected return on the market. So we really have a subset of the overall risk-adjusted performance measures where we have more the basic or naive versions, single index, related to the capital asset pricing model. So because this is really a set of ratios, there is a learning workbook associated with that. It's T1.3. The 3 is because this is the third reading in Topic 1, so it's an early reading. And then it's got some worksheets in there, 4 of them, although 3 have a low relevance here, and it's only the first one for exam purposes that you'd want to pay attention to, really, if your focus is just on the exam. And it's optional in any case, but as you know, the green high means this would be highly relevant for exam purposes. Now, there is of low relevance for exam purposes, but maybe of interest to others who, for practical purposes. This second sheet contains an illustration, actual calculation of the Sortino ratio, and that has low testability, not just because it's less popular, but because it's a tedious calculation. So it'd be unrealistic to expect you to calculate Sortino on the exam. However, you want to understand why we have it and why we would use it. But if you want to get you want to take a closer look, because there's 2 or 3 sort of nuanced decisions associated with this. This is actually interesting in application. It's really laid out in that second worksheet. The other 2 are really highly utility, low relevance. And so the learning spreadsheets, we'll see, I'm going to show you in just a few pages here a closer look at that first sheet in the workbook, which really lays out the risk-adjusted performance measures, the single index ones that we need to be concerned about. And so, but before we do that, let's just introduce the ratios and measures that are assigned here. And you can see the aim starts out with the Traynor, the Sharp, and the Jensen's alpha. So here's Traynor column, Sharp, and the column Jensen's alpha. So here's the ratios. Notice this Traynor and Sharp have the same numerator. And this is the expected excess return on the portfolio in this case. See how whenever we say excess return, that really suggests it's the return over the risk-free rate. So we're taking the expected return on the portfolio and we're subtracting the risk-free rate. So expected here, now sometimes that suggests we're doing what we could call an ex-ante calculation ratio. That is to say, before that performance has been realized on an expected basis. But we could, of course, calculate this on an ex-post, meaning after we have that actual return. So we've got the same numerator here, Traynor and Sharp, and the difference is the measure of risk. So see how these are risk-adjusted performance measures because we've got a return in the numerator per some unit of risk. And in the Traynor case, the unit of risk is systematic risk, beta. So you can see how already we're really true to the title of this assignment or reading. These really are single index performance measures. We're basing it on the capital asset pricing model. Although the Sharp ratio is different, whereas the Traynor is systematic risk, the Sharp ratio is what we could call total risk, volatility of the portfolio. So same numerator, different type of risk. And so here that's more spelled out. Both have excess return above the risk-free rate, where the denominator is the different type of risk. The Traynor, when would we use that? Well, we'd use that when the portfolio is well diversified and represents, when it's a well diversified portfolio and represents a portion of the investor's assets. The Sharp ratio, on the other hand, would be more appropriate if the portfolio is not diversified. Why would that be true? Well, because if we have a diversified portfolio, remember one of the assumptions there is that diversification is going to eliminate all of the non-systematic risk. There's going to be no compensation for that. So we don't need to capture, if it's well diversified, we by definition don't need to capture risk beyond the systematic risk. If it's not diversified though, we want to pick up the total risk, the systematic and the idiosyncratic risk. The Jensen's is also, this is Jensen's alpha, also based on the exact same capital asset pricing model. And you can really see the capital asset pricing model embedded in that, because we've got the expected return on the portfolio minus, notice what's in this parens here. I hope that you recognize this as the capital asset pricing model, right? We've got the risk-free rate plus beta, that is the quantity of risk, multiplied by the price of risk, which is the expected excess return on the market. So in this outer parenthetical expression, what we have here is what the capital asset pricing model tells us should be the return on the portfolio. So we take the expected return on the portfolio minus what it should be under our single index or single factor model. And the difference is the Jensen's alpha. So such that ex ante beforehand, we might not be, if this is a well-diversified portfolio, it's reasonable to expect that this would actually be zero, right? It's reasonable to expect that if all of our assumptions here hold up in our CAPM, that the difference between our expected portfolio return and what we would expect under the capital asset pricing model would be zero. But you can see how, especially from an ex post, after the portfolio is realized, let's say if this is greater than what we would predict per the security market line, then there would be a positive alpha. And then we could say that, oh, somebody who managed that portfolio actually produced positive alpha, which is to say distance above the security market line. Here in 2013, we have a GARP practice question. You can see I've highlighted that, just to show how the FRM might tend to quiz something like that. So this is sort of instructive. Look at the question here. Assume that you are only concerned with systematic risk. Which of the following would be the best measure to use to rank order funds with different betas based on their risk-return relationship with the market portfolio? And you can see here that that question is actually, without study, I think that's a tough question. But here, the key phrase is assume that you're only concerned with systematic risk. And then GARP is suggesting that the appropriate answer there would be the Traynor ratio. But that would require, of course, your understanding that not only that the Traynor ratio is excess return divided by beta, but that it's really a measure of systematic risk only. And then the second set of key ratios here is tracking error, information ratio, and that Sortino that I mentioned before. Tracking error and information ratio are both very common, very popular. So here we've got the tracking error is the standard deviation of that difference between the portfolio return and the benchmark, right? So this benchmark could be defined. Notice that's return of the benchmark. We can decide to define that. And then notice this tracking error then, so that can be viewed as a measure of risk because it's a kind of volatility, isn't it? It's just a volatility of what we've got here are also what are called active return, difference between the portfolio and the benchmark. So this tracking error could go into the denominator of the information ratio as the active risk, right? We're calling what's in parens here active risk, just the difference. But then if we're going to take the standard deviation of a series of active returns, then we're going to call the standard deviation of this the active risk. So once again, active return, standard deviation of becomes active risk. So the information ratio then you can see consistently is in this case is a measure of excess or active return, portfolio minus benchmark, divided by the same measure really, but in risk. So active risk, the same difference, but in standard deviation terms. And so now Noel Amenc is not the only author to reference information ratio. So it is the case that we have some variation in definition. So it is the case that information ratio can be defined in more than one way. Notice I pulled this out here. And the key here is, notice this from Garp's 2000 sample. We at Bionic Turtle, we actually informed this sort of thinking over the years, right, as information ratio, as we saw different authors defining it. And Garp has made a statement here that I fully support and I think is helpful. And the idea here is ratio consistency, right? So that means, notice, the information ratio may be calculated by either comparison of the residual return to residual risk or the active return to active risk. See how we can define it two different ways? But the key is we want to be consistent. In most cases, we want to be active return per unit of active risk. That's really suggested by here. Or if we want to be more technical, a little more specific, we can be residual return divided by residual risk. And I'm not really showing that here. I'm just alerting you to the fact that you can count on the question to be specific about what to use, or just to give you one set of assumptions. So don't worry about that too much. In most cases, we're going to be dealing with the simpler case which we can call active return. Again, active return is portfolio over benchmark, and then active risk is the standard deviation of the series of the same thing, return of portfolio over benchmark. The Sortino ratio is a downside measure to overcome some of these issues that might be related to these measures that are really indifferent. As you may know, volatility, it doesn't care if it's generated by up movements or down movements, but in fact, risk isn't really care about the up movements. Up movements are gains after all. Hence the idea of a Sortino ratio that we're only considered with really downside risk. And so there, the numerator is also an excess return, but not above a benchmark or the risk-free rate, but above a minimum acceptable return, MAR. So that would be selected by the user. And one special case of this could be the risk-free rate itself, right? So we could actually view this Sharpe ratio, if we like, as a generalized form of the Sortino. Or the Sortino is generalized of Sharpe, if you like, if you will. But the Sortino here is excess return portfolio over that minimum acceptable return. And then notice the ratio consistency. I like that as a guiding principle because it helps us keep in mind that if we're going to do that, if we're going to take return, that sort of return measure in the numerator to be consistent, then we wouldn't just use like a volatility in the denominator. No, we're using downside deviation. So that's a variation where we're also using the minimum acceptable return. Now, although this tends to be tedious, so I'm not going to go into detail on that, and I would refer you, if you're using the spreadsheets, to look at that page if you like, and talk about it on the forum if you like, because there are a couple. It's a little trickier than it looks at first glance. Let me put it that way. For exam purposes, what we really just care about here are what's in that first sheet of the workbook, in which I've pulled a snapshot out here just to illustrate. They're all right here on the right-hand side, the performance measures, right? These are really the four that we need to care about. We've got some assumptions for the market's risk-free rate, the expected market return, and then the excess market return is going to be the difference, right, between the market and the risk-free rate, so it's 6%. Then we've got a hypothetical portfolio with expected return, volatility, beta, tracking error, and the years we've observed it, so that's really not essential here. And then we've got our performance measures. So don't worry too much about the assumptions here. Rather, make sure that you understand how I got these calculations here, because that's the most testable aspect of the whole reading, right? Could you get the trainor on your own? And right, so let's look at that. The trainor is the portfolio's excess return, right? So that's going to be 14 minus the risk-free rate of 4. So the numerator is 10%. And let's just keep in mind, the numerator is going to be the same for both of these first two ratios. So we've got 10% as the portfolio's excess return. In the case of the trainor, divided by what? It's divided by the portfolio's beta of 1.5. 10% divided by 1.5 is about 6.7%. So you can say with the trainor. The Sharpe ratio, very popular, is in the numerator. Again, excess portfolio return. So 14 minus 4 is 10 divided by what? The volatility of the portfolio, 20%. So we have 10 divided by 20% is 1/2 or 0.5. What about Jensen's alpha? Well, remember that Jensen's alpha is the difference between what the portfolio returned and what the CAPM says the portfolio is expected. So what does the CAPM expect from this portfolio? Well, its risk-free rate of 4% plus portfolio beta 1.5 times the market's excess return. 1.5 times 6 is 9%, plus 4 is 13%. So the CAPM says that this portfolio with beta 1.5 ought to earn 13%. But its expected return is actually 14%. That's a difference of 1%, and that's a positive. So this portfolio is generating either, in this case, it's ex ante, but alpha of positive 1%. Then what about the information ratio? Well, we could take that 1% alpha, one way to do it, and divide it by the tracking error, which I've just notice I've just provided that as an input assumption, so we need to get bogged down in it. That 1 divided by 3 then is 1/3 or 0.333. And again, if you're tracking with me, pun intended, that you've realized this information ratio has more than one definition, that's a good thing. That's you're quite keeping up. And also, I would just suggest don't worry about it because GARP knows that there's more than one definition. You saw that sample extract I showed you earlier. They will specify which one to use, and more than likely, they'll give you only one set of numbers to worry about, right? Active return and tracking error. So you won't have to deal with that reality that we have two different ways to define that information ratio. Okay, so then here's a snapshot from the first sheet of that workbook. And if you're using the spreadsheet, then really all you need to know, almost all that you need to worry about for this section is really this worksheet, such that if you played with it a bit and understood what was going on, frankly, you'd be well prepared to handle this section of the exam. And so what I've got here, though, notice is several columns. Don't let that throw you off. That's not really a complication so much as I just copied these columns over. So there's really only one column that matters. Although notice I've got 4 columns here. And the reason I did that is just to illustrate to you how they plot here versus the security market line. So for example, this first column here, portfolio expected return is 5%. See that? And the beta happens to be 0.1 or pretty close to 0. So that security market line, right, is plotting that, or this chart is plotting that portfolio return against that low beta. And then we go here to the second column. That's an 8% portfolio, but its beta is higher at 0.6, so there it is. And then the reason I did that is to show you that at 1, 2, 3, 4 columns as we move to the right, these portfolios have higher and higher expected return. However, notice something. The portfolio with only 5% return is above the security market line, and the portfolio with a 13% expected return is actually below the security market line. So what is that? Why is that interesting? Well, this portfolio here has a positive alpha. Notice it's a positive 2.4% alpha, as does this one. But this portfolio over here, which has a higher absolute return of 13%, actually has a very negative alpha of negative 5.2%. That's the distance here from the security market line to that actual 13%, right? Because capital asset pricing model is predicting performance along this line. And so the reason I pulled that out is just to emphasize that our Jensen's alpha here in this row is just the distance between the portfolio's actually realized return and where the capital asset pricing model says it should be on this line. And so we can see now with the set of assumptions here, and there's a set of portfolio assumptions, we can then generate these risk-adjusted performance measures. And in that workbook, I have shown both versions there, alpha and alpha or residual return, residual return versus residual risk, or probably a little more common for us, the information ratio expressed as a function of the active return. Now, the workbook illustrates the Sortino ratio, but in the video here, I'm not going to go into great detail on that because there's just too many nuance issues. I'm just going to show you the snapshot here where the workbook simulates correlated returns between a benchmark and a portfolio, and over 30 periods you can see. And then that calculates here an active return, which is the difference between the portfolio and the benchmark. So you can see here 11.8 minus 5.5 is an active return per period. And then now this is a measure of downside risk. So instead of just a volatility, we calculate a downside deviation. And that downside deviation, that's the one where there's some technical choices we can make. But in this case, there's a downside deviation of 3.63%. Compare that, for example, to the same exact series where just the regular standard deviation is 8.71%. So the downside deviation there gives us a measure of the downside risk. So that's the denominator in our Sortino ratio. And then the active returns here are going to give us, are the start for our numerator. We're going to take the active return, the average active return, minus the minimum acceptable ratio, which in this case happens to be 5%. So that'll give us a numerator, and we have the basis for a Sortino ratio, which again, to recap, in the numerator is going to be average active return. Oh, I'm sorry. That's going to be average portfolio return over the minimum acceptable ratio of 5%. So that we're going to have a measure of the numerator divided by the downside deviation of 3.63%. So you'd only need to worry about that at this point conceptually. There's name that asks us to define the beta and calculate the beta of a portfolio. Obviously, this is thematic in the exam. Beta is the covariance between the positions and the market's return divided by the variance of the market's return. And so here's that key. Beta is covariance between the security and the market divided by variance of the market. And then also notice that if we sort of multiply, if we take this covariance and replace the product of correlation with the two volatilities, and then express this variance of the market as the product of two volatilities of market, then we can cancel one volatility per market. And so, as you probably know, or you should want to know, that we can take this beta expression and replace it with its equivalent here, correlation multiplied by cross volatility. See how if we just added in the numerator and denominator, if we multiplied by volatility of the market divided by volatility of the market, that we get back to this beta here. But see those equivalents here. Beta is also equal to correlation between the security and the market multiplied by cross volatility. And so here, by the way, then is a typical, very typical exam type question. Suppose the correlation of the return of a portfolio with the return of its benchmark is 0.8. So that's that correlation. And the volatility of the return of the portfolio is 5%. That's the numerator right here. And the volatility of the return of the benchmark is 4%. That could be this denominator right here. What is the beta of the portfolio? We can just plug those in if we're familiar that this is really just another way to express the beta. There's a couple here toward the end of the reading, a mention of the Morningstar rating system, which is relative return minus relative risk. And then also, maybe less common, but a VAR-based approach where notice the numerator is that familiar excess return, portfolio minus risk-free rate, but the denominator instead is replaced by VAR of the portfolio divided by an initial value of the portfolio. So that's a way to convert the VAR into percentage, isn't it? So now notice we sort of got another variation here on a Traynor and Sharp, because we have the same numerator here, an excess return in the numerator, but instead now yet another choice for what we could use for the risk measure. Instead of beta, instead of volatility, here we've got an interesting choice of using VAR in percentage terms. And then finally, the style or risk-adjusted performance measure, which takes into account the management style. And this is an illustration of actually Amenc 4.2.9.4, the actual example. That's why the numbers are so precise and not rounded. Mine would be more rounded. Here is the calculation for in this case, the risk-adjusted style performance measure. You can see here we have assumptions for the risk-free rate. Then the market portfolio has a return and volatility, so we're still in that mean variance framework. And then we have a fund and a style benchmark. And so, for example, the fund here, we can take the volatility of the market, which is 11.52%, divide by the volatility of the portfolio, which is 17.48%. That ratio then gets multiplied by the excess return, 17.48, minus the risk-free rate. That product gets added back to the risk-free rate. In this case, we would get a 0.64. And so the fund of 0.64 is minus the market return of 16.54%. You can see on that basis, this fund dramatically underperforms by negative 15.9%. However, relative to the style benchmark, 0.64 minus 3.08%, it still underperforms, but it's much less dramatic, only negative 2.44%. So that's just a summary exhibit of that final concept here, style or risk-adjusted performance measure. And that concludes the Amenc Chapter 4 on single index performance measurement indicators. Thank you.